What if your next car is a robot? Modern vehicles rely on sensors, AI models, and semiconductor technologies that are increasingly the same as the ones being used in the robotics industry. As their technologies converge, we are seeing the line between the automotive industry and the robotics industry starting to disappear. Some companies work at the intersection between software-defined vehicles, AI, and robotics. To understand where this convergence is leading, I spoke with Valentin from LG Electronics.
My name is Valentin Janiaut, and I work as the lead of our software customer success team for the automotive in LG Electronics. LG these days is really changing and transforming itself into what we call an AI-driven intelligent system company. Our focus today is on AI-defined vehicle, which is a new trend of technology where we use AI to create solutions from user experience in the cockpit, but obviously also autonomous driving solution, ADAS solution to help driving to better drive their car and perceive their car. Inside LG, we are also using AI, for instance, in HVAC to help cooling down AI data center, and we are growing our investment in robotics as well. So this is an area where we have a lot of synergy and I think a lot of growth potential in the future.
As AI spreads across intelligent systems, the boundaries between the industries are beginning to blur. So where do cars and robots actually converge?
Obviously, there's a lot of similarities between robot and car these days in terms of sensors, in terms of overall architecture, having a central brain to be able to control actuators and getting the information from the sensors. Those two industries are sharing a key challenge, a common challenge, which is how you decouple the hardware and the software. And traditionally, both in automotive and robotics, the software is so tightly coupled with the hardware solution. And it's very hard to have development of software independently from the hardware. Both industries have not yet found a real good solution. But I think there's a lot of things we have to learn from each other in terms of solution and how do you create an independent software platform that can be used across different hardware products, different vehicle or different robots. And I think it's an area where there is interesting synergy to look at and development to do.
For a machine to act autonomously, the first challenge is perception. It needs to understand its environment. The perception technologies that are used in robotics and the autonomous vehicles, are they essentially the same or are there differences between those two technologies?
In the same way that there is this challenge of decoupling the hardware and the software, the challenge around perception is very much the same. And there has been a long debate in the automotive industry. Is camera enough? And we all know Tesla really strongly believe that camera perception based is enough. A lot of car makers are using also LiDAR technology. And you see the same kind of challenge in the robotics. And you see robots rely only on camera for their perception stack and robots using also LiDAR, which give obviously more information. We have a lot of commonality in trying to address those issues. We have also to highlight the big difference. When you're driving a car at 100, 130 kilometers per hour, the margin for error in your perception stack is much smaller. With a robot, depending on the environment and how you use the robot, the margin for error in your perception stack is a bit more acceptable. So I think the main difference today is really around how much error can you accept in your perception stack and how much redundancy you need to have. And in that sense, in the automotive industry, LiDAR is quite a good solution to have sufficient redundancy in bad weather or low light environment and so on, where LiDAR is much less impacted by those differences.
So basically it's mostly with the safety concerns.
Definitely the safety is the key point for automotive. In the robotic, when you use the robot in a factory environment or in a more controlled environment, perception can be a bit less critical.
Once machines understand their environment, the next step is deciding what to do. Should a vehicle brake? Should a robot avoid an obstacle? Should a drone change trajectory? Making the right decision depends on experience. The more situations a system has encountered, the better it can react to new ones. And one industry has spent decades collecting far more situations than the other.
The big advantage we have in the automotive industry is that we have really a lot of driving data. And when you look at it, the driving data is what really matters to train those systems. So a lot of the autonomous driving solution we see on the market today are coming from actual deep neural network approach where you do a machine learning and you train those systems based on hundred and hundred of thousands of driven kilometers with actual data. Where robotics is a bit more struggling, and we see a robotic company trying to invest more in building, acquiring those data sets. The algorithm might be the same, but the key challenge was around the data for the robotic. And then we saw recently like those vision-based model derived from LLM, from large language model, doing surprisingly well in robot. But clearly, this is not a viable solution for the autonomous driving vehicle. Like the level of safety would not be there. But there is an area, and where LG is actually also working with our LG X1, it's around word model. Can we actually create an AI capable of understanding the physical world? Because today, those models do not understand the physical world. They just react based on training of data and trying to repeat the same situation from previously observed and infer what is the best approach. If you have an AI capable of understanding the physical rule of the world deep inside the weight of the model, we do expect excellent results and very important for the robotic. But there is a hope that such model also will be helpful for the autonomous driving vehicle.
Another area where convergence is happening is computing hardware. Processing sensor data and running AI models requires enormous computing power. And increasingly, both industries rely on very similar hardware platforms. When we look at the semiconductor ecosystem supporting the automotive industry, is it essentially the same that can support now the robotics industry?
The automotive industry is still relying on very strict qualification rules for their chipset. It's called AUTOCRYPT, which means because you have such strict requirement on the thermal, the environmental of the chipset, automotive industries are a little bit behind compared to other industry where those requirements, like when you have a robot operating inside a warehouse or inside a control environment, the hardware requirements are less strict, but the gap is closing more and more. All the big players in that field, whether it's Qualcomm, whether it's NVIDIA, invest equally for both automotive chipset, robotic chipset, and so on, and share, I would say, not maybe the chipset itself, but the technology underlying those chipsets is being shared more and more across those different industries for sure.
And I heard that LG works with NVIDIA in that area, right?
Absolutely. We just announced a large partnership with NVIDIA. And in an interesting way, when you look at the partnership announcement from LG and NVIDIA, it's both for the robotic part of LG, where we have big ambition, but also from the automotive part of LG, where we use NVIDIA solution in automotive business as well.
But sharing hardware is only part of the story. The real challenge is the shift from hardware to software. In the automotive industry, this shift is embodied by software-defined vehicles, or SDVs, where software increasingly determines how a vehicle behaves and evolves over time. How do SDV architectures, or what we call SDV architecture today, differ or relate to the robotics architecture? Can we apply them to the robotics architectures?
If you look on the paper, that there's a lot of things that should be shared across robotics and automotive. You have similar requirement in terms of real time, or in terms of sensors, creating action to a system. And a lot of those software blocks should be the same. Personally, wish that we could achieve a common platform between robotics and automotive. There is such initiative. When you look at a company like Apex.ai that LG invested in, that's basically what they are trying to achieve and use their solution in both robotics and automotive in terms of operating system, in terms of framework. But the reality is that there is a lot of initiative going on in the automotive industry. You can look at AutoSAR, you can look at Google SDV, you can look at the more recently announced S-Core, which tried to build an open source platform for this. In LG, we always support open source initiative. LG is a member of S-Core, but it's a challenge for the industry to find a good synergy and a good reuse of those software assets because it's pretty wasting time. Like there is very limited value in building a middleware. But the reality is that still where a lot of the companies are spending time and effort. I think automotive has a lot to learn from robotic for those challenge and look at how we could have more synergy in this area. We can hope that in a few years we might have a platform emerge, an open source platform. But at this time, it's still a very fragmented area.
Building a common platform is not just a technical challenge. It also requires solving difficult questions around governance and business incentives.
There is obviously tension around the business model behind it. And I think you have to, when you invest in those initiatives, there is a question on your return on investment. And how do you build sufficient business opportunities for all the stakeholders in those platforms and those initiatives in a way that's fair, that is meaningful? How do you manage governance? The industry as a whole has not been able to find solution for.
As the robotics and automotive industries are increasingly relying on the same technologies, tech companies are beginning to combine their R&D efforts across both sectors. Do you think this will eventually lead to a closer collaboration between the two technological ecosystems?
It's very obvious when you look at that LG-NVIDIA partnership I was discussing before. That partnership covers both automotive and robotics. NVIDIA being an important player in that market and trying to work with other companies who share this vision of what I was discussing at the beginning of physical AI, of AI-driven system solution company, applying AI to complex system, complex hardware. And I think that's where there's that convergence, which is driven by those AI solutions that can now be applied across different hardware complexity that are not just a gadget or something, a better user experience in your phone, but that really address industrial problem in those industries. We had just an automotive ecosystem, but I can see the ecosystem growing beyond automotive. There will be probably at some point an interest to look at how do we have synergy for a software solution for both robot, for both automotive, and look at how we can create those better ecosystem across this industry.
The automotive industry is actually the client for the robotics industry, because a lot of robots are actually sold to the automotive industry.
You need robot to build more robots. And I think you might see car as being just a category of robot in the future. We are seeing robot emerging as a way more broad and wide category of hardware solution. And so you might see need of having robot as a basic requirement for a lot of other industry. And I think automotive industry will definitely be one of those industries that will consume a lot of robot as well for their production. And we might imagine for other services as well.
In spite of the challenges, converging industries are not that uncommon. A decade ago, the automotive industry underwent a very similar shift.
When I first joined the automotive industry, like about 15 years ago, I think there was a convergence between the consumer electronics, phone, eventually TV, but all that experience you had with consumer electronics was the beginning of the smartphone era at that stage. Automotive industry being, over a century and a half old, it was very challenging to convince automakers to use consumer electronics technology and approach. And I think for me, it's been a very great journey at LG to learn how to help automakers improve their experience in their cockpits with our technology. And when I look at robotics, I find a new sense of excitement. We kind of always dream of having a robot at home, of what we call in LG a zero labor home. We are getting close to make those things happen. For me, it's quite interesting to be contributing very modestly in those new technology and those new development happening, and making people having better experience in their car and having better experience in their home and in the city with robots technology as well. So I'm definitely excited for what the future holds for us.